In this video, we're going to talk about solving a system of linear equations. For this particular system, we'll use row operations to help us solve it. Allowable row operations are as follows. We can interchange rows we can multiply rows by non-zero constants. Also, we can add multiples of one row to another. These are what we call our allowable row operations. So let's get started. Here I've rewritten the system from the previous screen, and for our first row operation, we're going to take 2 times R1 plus negative R2 and store it in R2. This gives us 2 row 1 is 2x plus 2y plus 2z plus 2w equals 12. And we're going to add that to negative row 2, which will be negative 2x minus 3y plus w equals 0. The 2x and negative 2x cancel out. We're left with negative 3y plus 2z plus, we're left with negative y plus 2z plus 3w equals 12. So then we rewrite our system, keeping rows 1, 3, and 4 in their original form, and making our updates to row 2. So now we have our new system. So I've copied in our new system from the previous step, and now we're going to perform the next row operation. The process that we're using is to work toward getting this system into row echelon form, or at least working in that direction until we get a solution for one of the variables. From there, we'll use back substitution to help us solve the remaining variables. A system in row echelon form has a stair-step pattern where each row has a lead coefficient of 1. For our next step, we're going to take 3 times row 1 and add it to row 3. We'll store our result in row 3. So here's row 1, and here's row 3. We're going to take 3 times row 1, and add it to row 3. So our x's cancel. We're left with 7y plus 4z plus 5w equals 22. And this gets stored in row 3. And let me just write down our step. This was row 3 equals 3 times row 1 plus row 3. So now we'll set up our new system. So with our new system, we proceed to our next row operation. So now, looking at our most recent system, our next step is to take row 1 plus negative row 4 and store it in row 4. So we have row 4 is equal to row 1 plus negative row 4. Where row 1 is x plus y plus z plus w equals 6, and row 4 is negative x minus 2y plus z minus w equals 0, where our x's cancel, our w's cancel, and we're left with negative y plus 2z equals 6 in row 4. Let's rewrite our new system. So now we take our most recent system and set up our next step, which is to interchange or swap row 3 and row 4. So here's our new system with rows 3 and 4 interchanged. For our next row operation, we're going to distribute a negative 1 across row 2. So and we'll store it in row 2. So we have row 2 equals negative row 2. We simply flip the signs for all entries in row 2. So our new system looks like this. So working with our most recent system, and moving on to our next step, we have row 3 equals row 2 plus row 3. So we're adding row 2 and row 3 and storing it in row 3. Our y's cancel, our z terms cancel. We're left with negative 3w equals negative 6. So we know that the value of w is equal to 2. And now we can substitute this value back into our system. So now for our system, we have x plus y plus z plus 2 in place of w equals 6. We simply put a 2 wherever we had a w before. So this negative 3w becomes negative 3 times 2, which is negative 6, equals negative 12. Then since we added row 2 and row 3 and got negative 3w equals negative 6, we know that w equals 2, so negative 3 times w gives us negative 6 equals negative 6, which is a true statement. And for our last row, row 4, we have 7y plus 4z plus 5 times 2, which is 10, equals 22. So here's our most recent iteration of our system of equations. And our next step will be to take 2 times row 2 plus row 4 and store it in row 2. Our 4z and negative 4z cancel out. We have 9y minus 2 equals negative 2. Solving for y, our 2's cancel. We have 9y equals 0, or y equals 0. So now we have the value for another variable. We'll substitute it into our system. So we have x, looking at row 1, x plus y, where y is 0. So we have x plus z plus 2 equals 6. And then for row 2, we have y minus 2z. Since y is 0, we don't need to write it. So that's minus 2z minus 6 equals negative 12. Then row 3, we have minus 6 equals minus 6. And for row 4, 7 times 0 for y cancels. So we have 4z plus 10 equals 22. From here, we can see that it would be fairly easy to solve for z using row 4. Subtracting 10 from both sides gives us 4z equals 12. So we know that z is equal to 3. So now we know that w is equal to 2, y equal to 0, and z equals 3. We can take a look at row 1 of our matrix. So we have x, let me change the color here. We have x plus 0 when y was equal to 0, plus 3 when z is equal to 3, plus 2 where w is equal to 2 equals 6. This gives us x plus 5 equals 6. So we know that x is equal to 1. So to restate our solutions, x equals 1, y equals 0, z equals 3, and w is equal to 2. This concludes our example of solving a system of linear equations. I hope you found it helpful, and we'll see you next time.